12th graders. So we are going to talk about today, we've already been introduced to like the general idea of what hypothesis testing is. And what we're going to talk about today is specifically your chi-squared testing. So your chi-squared testing is one that you hear a lot about with statistics. So this is one that's very commonly discussed and used. And there's two different, and a big reason why is because there's two different chi-squared statistics tests that you can do. And they're used for two different reasons. So you can do a chi-squared test for goodness of fit and a chi-squared test for independence. So a goodness of fit test is testing whether it fits well, but more specifically, testing if data comes from a specific distribution. Now, we can be talking about like a binomial distribution or a normal distribution, but it could also just be like, hey, I noticed this pattern last year and I want to know if these points of data are following the same patterns that I had last year. And so that's pretty much what the chi-squared goodness of fit test is that you're saying like, hey, is this following a pattern that I expected to be following? Versus the test for independence is exactly as it sounds, it is testing if variables are independent. So two very different questions. And so you'll see this this symbol a lot in questions where they're like, okay, determine a chi, or like follow the chi-squared test. But you need to very specifically look for, are you checking for goodness of fit or are you checking for independence? Because there is actually a difference in how we approach it. So we're first going to just talk about goodness of fit, and then we'll come back to your test for independence in the second half of these notes. But here's a few things that you need to write down for goodness of fit, and they mostly deal with vocab. Okay, so we talk about observed frequencies. Like when we're plugging these values into your calculator is going to be like, which one of these are your observed frequencies? And the observed frequencies is the data we are given. Typically. We know that in IB that things cannot necessarily follow a certain path that they normally always do. So typically it's the data that we're given. It's the data that we've seen or that we're talking about right now. It tends to be like the new data. So for instance, somebody tested in our example down here, somebody tested a certain type of language. These are the observed frequencies, and you typically have to go in and calculate what the expected frequencies are. So that's the other half of your observed frequencies are your expected frequencies. The expected frequencies are the frequencies given the distribution is true. So if it was a normal distribution, then you would have to go in and find out what is the expected frequency of this number from a normal distribution. What is the expected frequency if what I normally expected to be true before, what would I expect this value to be then in the future? And so we'll talk about how to calculate that later. Another thing that we talk about are degrees of freedom. It's a parameter, I guess, of your chi-squared test for goodness of fit, as well as for independence. So the parameter of your chi-squared tests is always this idea of degrees of freedom. Degrees of freedom is represented by V, and for your goodness of fit test specifically, it's N minus 1. So that is a formula. N is number of groups in a table. So for instance, there are 3 groups in this table, Spanish, German, and Russian. So your degree of freedom would be 3 minus 1. So for this instance, your degree of freedom would be 2. So those are all different terms that you'll see that go along with the chi-squared goodness of fit test. So let's go ahead and jump right in and practice it. A school offers a choice of 3 different languages. Lorenzo knows that in his year, a third of the students selected Spanish, a fourth selected German, and 5/12 selected Russian. In order to investigate whether the choices in the year below follow the same distribution, so checking to see whether it follows a certain type of distribution, not normal, not binomial, just like any type of distribution, this type of distribution. He selected a sample of 60 students. These are what their choices were. So this is the observed frequency. Whereas up above here with these probabilities, we are going to use these probabilities later to then determine what our expected frequency would be. It says Lorenzo conducts a chi-square test at the 5% significance level. Okay. We're going to state the null and alternative hypothesis. So the null hypothesis typically is following along this idea of everything maintains the same. So your null hypothesis always is like everything maintains the same, nothing changes. And so going back through and determining this, your null hypothesis with this idea of everything stays the same is that the distribution is the same from Lorenzo's year. So Lorenzo observed this distribution, and so the null hypothesis is that it stays that same distribution. So the distribution is the same. From Lorenzo's year. Versus your alternative hypothesis is just that the distribution is different. So it doesn't say at all here, in order to investigate whether the choices in the year follow the same distribution, he selected these and then conducted a test. There's no indication here that we're saying like that the distribution is greater, which doesn't really make sense because distribution deals with certain types of probabilities. So we would just say that the distribution is different. The number of degrees of freedom. So that's your variable v. You've got 3 different categories. So subtracting 1 away from that, you've got a degree of freedom of 2, as we talked about earlier. Fill out a table of observed and expected frequencies and calculate the chi-squared value and the p-value. So this is where the mathy part comes in. So this is where we're going to talk about something that's fairly new. What we first need to do, we have the observed frequencies. We need to first calculate the expected frequencies. And so I'm going to do that up here. Our expected will be here to the side. And it's much more simple than I would imagine you think it is. So if it says that in his year, a third of the students selected Spanish, then our expected value would be a third of the total sample that he gathered. And so we need to find out what is a third of 60 to determine what is the expected value for Spanish. So 1/3 of 60. So 60 divided by 3 is 20. So our expected value would have been 20. That if it followed the same distribution and that a third of the students selected Spanish, that means that it would be 20 out of the 60 students were taking Spanish. Same thing with German. We take the probability for German, which is 1/4, and multiply it by the total number of people that we talked to. And that a fourth of 60 is 60 divided by 4, which is 15. And then Russian, 18 5/12 of a probability. Go ahead and tell me what that is. 5/12 of 60 is 25. So these are our expected values. So that's the first step. We can even write down a set of steps if you would like. Step 1 down here, create expected values. You can even write down probability times sample, right? The probability of Spanish is 1/3 times the sample size, which is 60. So that could be like a set of instructions for you if you're an instructions type person. Okay, and then we need to find out what is the chi-squared value and the p-value. And how we're going to do that is with our calculator. For your goodness of fit test, you can do your chi-squared test in your stats list. So we have a brand new fresh stats list right here. I'm going to go ahead and input in my observed frequencies in column A and my expected frequencies in column B. Once I have done that, in order to get to my goodness of fit test, I would hit Menu, Statistics, and instead of doing a stat calculation, we're going to do a statistics test. So this is the next level of statistics, is that we're doing tests now instead of calculations. So the test that we want to do is our chi-squared goodness of fit test. So I press 7. Oops. 4, 4, 7. The observed list is in column A. The expected list is in column B. My degrees of freedom is 2, which I found earlier. I'm going to put my results in column C. And here we go. We've got a chi-squared value right here. Our chi-squared value is 3.83. And our p-value is just right below that. The p-value is 0.148.